Everybody, in this video, I want to keep introducing polynomials and just really formalize the definition a bit and also talk about something called degree more formally as well. So something like this, let's see. Is an example of a polynomial in standard form. And you want to know that typically in standard form, your powers or your exponents are descending, or you can also say decreasing. In math, we typically say descending, so that's an S there. But it just means that they are decreasing. So we tend to like to write our polynomials in this order. And the formal definition of the polynomial looks like this. Okay. Now what we see here is just that we have powers for all of our variables, and they are decreasing. So if your first power is n, then your next power is that value -1, and then the value -2, etc. So they're just kind of going in decreasing order. And all of these values out front are your coefficients. They're just different numbers. Now, one thing I want to point out about polynomials is that your powers are whole numbers or your exponents. And that is really important with polynomials. So you can see here, all of our powers are whole numbers. They're all, no fractions, no decimals, no negatives even. So things that are not polynomials would be something like 3x to the 1/2 power minus 4x squared plus 2x minus 5, right? So we're not going to have any powers that are fractions or decimals. We're also not going to have any powers that are negative. Right, so no negative powers. And again, there shouldn't be anything really weird going on, so we don't want any dividing by variables either. Okay, so for our polynomials, they're sort of as nice as possible as you can get after linear. So they're definitely a step up. They're a little bit more complicated, but your power should be as simple as possible. So nothing too complicated going on here. You can have polynomials in more than one variable as well. So let me focus on just one variable first, which is what I'm doing here. And then we'll look at some examples where you have more than one variable. Okay. So we have a definition which is called degree. And it says that if a is not equal to 0, the degree of ax to the n is n. Also, the degree of a non-zero constant is 0, and actually the degree of the constant 0 is not defined. So for example, let's say you had, oops, sorry about that, guys. Let's say you had something like 4x to the 5th. The degree equals 5. Or if I have 2x cubed, the degree equals 3. If I do not have a variable there, so let's say I just had the number 1, then that has degree equal to 0. It doesn't matter if your coefficient is positive or negative either. So if I want to make this a -2, then that's okay. It's still going to be the same degree here. Now, this is all for individual terms or monomials here. So what happens when you actually put it together as well? So let's say you have an example that is more than one term. Maybe I have 4x to the 5th plus 3x to the fourth minus x squared plus 2. So what you do in this case is you take each of the degrees. So the degree here is 5. The degree here is 4. The degree here is 2. And the degree here is 0. And then when you have a more complicated polynomial like this, you take the overall largest. In this case, which is 5. So if you have something that is more than just one term, you can also find that degree as well, but you take the individual degrees first and then take the biggest one. So this one has overall degree 5 here. Now, in this video, we're not going to do much with degree, but if you continue into upper level mathematics classes, you're going to see that the degree is actually really, really important. It tells us a lot of information about what the graph looks like, and also how many solutions we can have when solving these style equations. So it becomes really important in upper mathematics, again, just for help finding solutions to equations, for help with graphing, etc. So it is a really important piece. For our purposes, we're just going to work on how to find it, but know that it is used in other classes in more detail as well. Let's do one more example here, and then we'll go on to variables or polynomials with more than one variable. So maybe I have something that is negative 2x cubed plus 4x squared minus 1. Okay. Now notice that my powers are in descending order. You do want to be careful there. It's nice to have them in that order. It makes things easier. So my degree here is 3. My degree here is 2. And my degree here would just be 0. So if you have a constant, it's just 0. And then what we're going to do is we're going to take the largest one. So the degree of this polynomial is 3. Other things that we like to note here, so the degree is a really important one. So going kind of back to our formal definition here on the previous page, now that we've worked a little bit with it, this one here, what you're going to notice is that the highest power or highest exponent is going to end up equaling your degree. And then we call the first coefficient that is with the highest power the leading coefficient as well. Okay. So this is actually, again, another thing to just kind of keep in mind. For now, we're just finding it, but really this first part of your polynomial here, so this part right here, is sort of your most important. So that right there is your leading coefficient. And that n is going to give you your degree. So an example up here, that would match with 5 being our leading coefficient, and our degree here would be 4. Okay, so they're just kind of going back to that formal definition of when you have just one variable polynomials. Now, you can also have polynomials in more than one variable. So for example, maybe something like negative 2x cubed y plus 4xy minus 5y squared. So here I have two variables that are being brought in. It's still a polynomial. So for polynomial, again, the big thing is that your powers are whole numbers. Okay. It's okay to multiply variables together. That is fine, but I'm not dividing by any variables, okay? You can have fractions, that's okay. Okay, so that's another example. But as long as those powers are whole numbers, okay? So you can have it where you have variables being multiplied, or you may have them separate, it doesn't matter, but you have more than one variable in that example. Now, when you're finding degree here, you actually add up all exponents of the variables on a term to get the degree. Sorry about that, guys. Let's fix this. All right, joys of working from home. We have animals running across the screen. All right, there we go. So for example, let's say I had something like negative 2x cubed y to the fourth. So I would just look at the exponents on my variables and you add those up. 3 plus 4 is going to be 7. So the degree there is 7. Or let's say I had something like negative 4y squared z. Now, if there is no variable exponent noted, there is a 1 there. So here it would be 2 plus 1, which is 3. Or we'll do one more. Maybe I have 1/2 x to the fourth y squared z. Okay. So here I have 3 variables. That's absolutely fine. We can add up all exponents. 4 plus 2 is 6, plus 1 is 7. Okay. So very similar concept, but we're adding up all the exponents on the variable. And then if you want to have a more complicated example, I'll do one of the ones I posted above. We still follow the same rule as before. You find the degree of each piece. So the degree here is 4, right? 3 plus 1. The degree here would be 2, 1 plus 1. And the degree here is also 2. So we just take the biggest one again. So the degree of the polynomial is 4. Okay, so very similar process. It's just that when you have more variables within the term, you want to add up those exponents first, and then you still take the overall highest degree. I will note as well that it is hard to write things in descending powers when you have more than one variable. We usually just sort of do the best we can. You know, for something like this, I wrote the power of 3 first and then squared. Here, 3 before the square, but I left the x, y in the middle. So sometimes we'll put our higher powers on the beginning and the end if they have different variables. It's really not as straightforward. So if you have mixed variables, we just sort of do the best to write it in what seems to be the nicest way. But there's sort of no true standard form like there is when you have everything in x or in one variable where you can clearly write them in descending or decreasing powers.